Okay, here's the last page of the study guide. Find the volume of the rectangular prism, which is, remember, a volume of a rectangular prism is essentially a box. Here's and so the volume of a rectangular prism is simply the length times the width times the height. It doesn't really matter what we're calling the length, width, and height, so long as we get the dimensions in each direction. So there's this dimension, and then there's this dimension. So in this case, if I call this the length, I call this the width, and I call this the height. So that means my length is 6 yards. My width is, I'm going to multiply that by 8 yards. My height, I'm going to multiply by 15 yards. So I have 6 times 8 times 15 times yards times yards times yards. Right? There's yard there, there, and there. So let's see, is there an easiest way to do this? 6 times 15 is 90. So I have 90 times 8. 90 times 8 is the same as 9 times 8 with a 0 tacked on, so that's 720. And how many yards do I have? I have 1, 2, 3, and multiplying together, yards cubed. And that's the way it should be, because volume is always a cubic measure. Remember, what you're doing is you're filling up this container with cubes. So you're actually counting how many cubes can fit. In this case, the cubes are of size 1 yard, so this is a pretty big box. But the volume is this answer right here. Determine the side labeled x, and these are similar figures, so this is good to note. For similar figures. When you say two figures are similar, they're telling you that they're exactly the same shape, but they're different sizes. And I can see, when I compare these two, that this is bigger than this. And these two sides here are the same, just as these two sides. And this side is half of this side. So this is half of this, and this is half of this, which means this x must be half of 8. So x is 4. That's all that one is. Order the fractions from least to greatest. Now the challenge with the way it is right now is all these fractions have different denominators, so it's hard to compare them directly. So what we need to do is we need to change them so they all have the same denominator. And is there a number that has 12, 8, 24, and 6 as a factor? And yes, and the answer is 24. Because I can multiply 6 by 4 and get 24. I can multiply 8 by 3, 12 by 2. So let's first change everything so the denominators are the same. So 7/12, if I multiply it by 2, top and bottom, so whatever I do to one side, I have to do the other, I have 14/24. So 7/12 is the same thing as 14/24. Now let's do 5/8. As a matter of fact, I'm going to write what I'm multiplying by in a different color so I kind of see it a little differently. This time I have to multiply top and bottom by 3. So now I have 15. 3 times 5 is 15. 3 times 8 is 24. So I have 15/24. So 5/8 is the same thing as 15/24. 13/24 I don't have to change. So the only thing I have left to do is check 5, 6. So if I multiply this by 4, I have to multiply the top by 4. So I have 20/24. So 5, 6 is the same thing as 20/24. Now from least to greatest, which is the smallest? Well, I have 13/24, 14/24, 15/24, 20/24. Well, 13/24 is going to be the smallest, followed by 14/24 or 7/12. Because I have to order these fractions from least to greatest. After 14/24 will come 15/24 or 5/8. And that leaves me with 5/6. So there's these fractions ordered from least to greatest.